Hello, we are discussing about GATE 2013 ECE paper, and the question is related to electronics. Look at the circuit diagram. For the circuit shown, the knee current of ideal Zener diode is 10 milliamperes. To maintain 5 volts across the load RL, what is the minimum value of RL in ohms, and what is the minimum power rating of Zener diode in milliwatts? Okay, we are going to calculate minimum value of RL as well as minimum power rating of Zener diode. Out of the options given A, B, C, D, the right option is B. Okay, the minimum value is going to be 125 ohms and the minimum power rating is 250 milliwatts. Okay, so we will see how to calculate this one. What was given is nothing but the knee current of ideal Zener diode. Knee current is called as knee current, or it is also called as IZ minimum. The minimum value of Zener current required to keep the Zener diode in breakdown region is going to be called as knee current, and that was given as 10 milliamperes. 10 milliamperes. And to maintain 5 volts across the load, so across the load RL we have to get 5 volts, so V0 is going to be equal to 5 volts across this one. So we must use a Zener diode of 5 volts. So given that one, Vz is also given as 5 volts. Zener diode voltage is given as 5 volts. Output is constant at 5 volts. We are going to calculate the value of RL is going to be minimum. So we are going to calculate RL minimum. So minimum resistance is going to be possible whenever the load current is maximum. So we can say this as IL maximum. So whenever a maximum load current is flowing, then only we can calculate minimum load resistance for the given output voltage. So we will calculate these parameters in this way. Okay, this is what the circuit. Let us assume this is the current flowing through this branch is nothing but I. Okay, and the same current is flowing through 100 ohms, and this current is divided into I load as well as IZ. So this load we are going with L itself. Okay, so from this one we can say it as I is equal to the total current I is equal to IL plus IZ. IL plus IZ, and the value of this one can be calculated because this is the current I which is flowing through this 100 ohm resistor. So for this 100 ohm, if you know the voltage difference and divide that voltage difference with 100 ohms, so you will get the value of I. I is equal to 100 ohms is connected with 10 volts and 5 volts, so that I can be written as 10 minus 5 divided by 100 ohms. So this is 5 by 100, which is nothing but 50 milliamperes. 50 milliamperes, which is constant. Remember that one. Since both sides of that resistor values resistor voltages are going to be constant, current flowing through that resistor I is also constant. So that current is dividing into load as well as Zener diode. I is equal to IL plus IZ. But if you are going with some extremities, at that time we can write these equations. So extremities is nothing but if the current flowing through the Zener diode is maximum, by that time we can write the equation as if the current flowing through the Zener diode is maximum, so by that time it is I is equal to IZ maximum. By that time how much current is going through load is nothing but that is the minimum load current. So we can write it as minimum load current. Otherwise we can get the same equation in this way. I is equal to, if the Zener is going to be taking minimum current, IZ minimum, by that time load should take maximum current. Because the current coming is constant, so that if Zener diode is taking minimum current, load has to take maximum. Otherwise if the load is taking minimum, Zener has to take maximum. So out of these two equations, what we require is nothing but to calculate RL minimum, we require IL maximum value. So we will use this equation. I is equal to 50 milliamperes and IZ minimum is given as 10 milliamperes plus IL maximum. So IL maximum can be calculated as IL maximum is equal to 50 minus 10, which is nothing but 40 milliamperes, which is 40 milliamperes. And from this one RL minimum RL minimum is nothing but V naught divided by IL maximum. V naught has to be at 5 volts divided by 40 milliamperes. So the RL minimum value is 125 ohms. So, and we are going to calculate what is the minimum power dissipation rating of Zener diode. So Zener diode should not get break. Okay, so Zener diode current rating is going to be generally specified as current rating of Zener diode. Zener diode is IZ minimum to IZ maximum. IZ maximum. So Zener diode has to withstand from IZ minimum to IZ maximum so that it can be in the breakdown region without getting break. Okay, and the voltage rating of the Zener diode is nothing but V, voltage rating of the Zener diode. So in breakdown region, what is its value is nothing but Vz. So the diode should be chosen such that even though the maximum Zener current is going to be taking, by that time also Zener diode should not get breakdown. That implies nothing but minimum power dissipation PD, that is PZ minimum power dissipation across Zener diode has to be such that even though the maximum current is flowing in the extreme case, okay, by that time also you should not get break. So that implies nothing but we can write the equation like this: Iz maximum into Vz. Iz maximum is nothing but Iz maximum is nothing but if IL is itself is going to be minimum. Okay, so Iz maximum can be equal to I itself. Iz maximum is nothing but maximum Zener current. If there is no load current at that time, the total 50 milliamperes current has to go through this Zener diode only. So that Iz maximum can be at most 50 milliamperes into 5 volts is a Zener rating. So PZ minimum is nothing but 50 into 5 is 250 milliwatts. So the minimum power dissipation rating of Zener diode is 250 milliwatts and the minimum load resistance is 125 ohms. To maintain output is at 5 volts. So the right answer for this question is RL minimum is 125 and PZ minimum is 250 milliwatts. Right option is B. Thank you.